It's Stan Veit's History of the Personal Computer. From Altair to IBM, a history of the PC revolution. By Stan Veit, Editor-in-Chief Emeritus, Computer Shopper. Copyright 1993 and 2011 by Stan Veit and A-Books Creativity Incorporated. Read by David Greelish, ClassicComputing.com. Chapter 4. Southwest Technical Products, M6800, the Friendly Computer. Southwest Technical Products, SWTPC, was the most unusual of the early personal computer companies. First, it lasted the longest of all the pioneers, and second, it existed before the start of the personal computer age and contributed as much as MITS or MSI in establishing it. In addition, it was always owned by one man, Dan Meyer, whose personality and ideas determined the products it made and the way it did business. SWTPC was also unique in that it made a complete line of computers, peripherals, and software, and made most of the parts in its own factory. Southwest established its own unique bus architecture, the SS50 bus, which came to be used by several other manufacturers. In spite of this, it's a safe bet that most of my readers have never heard of Southwest Technical Products. One day, a tall young man came into the store and asked, "Do you have any Switz?" Kelvin Smith, my manager, not knowing what was meant more than half the time when the computer nuts asked something, repeated, "Stan, got any Switz?" So I came out of the back room and asked the kid, "What's Switz?" "I mean Southwest Technical Products, M6800 computers, Switz," he replied. "Well, no, but I have Sphere 6800 computers." "Junk," the kid answered. "How can you call this a computer store if you don't have Southwest?" "Go on, beat it," I snarled. I was tired of being told off because I didn't have everything advertised in Byte. He left. Some time later, I went to a meeting of the Amateur Computer Club in New Jersey, and a 14-year-old named Todd Loofborough showed a computer he had built. It was a small black box with no front panel, and it looked a little like an audio power amplifier. I was finally seeing a Switz. The demo was astounding. The computer worked, ran software, and powered a teletype. I was impressed. When I returned to New York, I spoke with Leslie Solomon, technical director of Popular Electronics magazine, about it. "Sure, SWTPC is one of our oldest kit makers, and Dan Meyer, the owner, is a great guy. You ought to sell his computers." So I called Southwest in San Antonio, Texas. "Mr. Meyer," I said, "I'd like to sell your computer line in my computer store." "No," Dan replied. "I sell them myself, by mail. I don't sell through stores." "Well," I answered, "computers are something new. It's not like your audio equipment. People want to see how they work before they buy them. Les Solomon says I should sell them." "Les says that? Okay, I'll give you 25% discount and ship you 10 computers as a trial. You'll get 5 this week and 5 next week. You pay me in 30 days or we're finished." My God, he was offering me 30-day credit. Nobody else in the industry gave any credit. They even wanted prepayment. The 5 computer kits arrived on time, and I took one home and built it. It was so easy, even I could build it, and I was a slob with a soldering iron. A week later, the tall kid was back. "Heard you got Switz. Now you're cooking. Would you like me to bring in my video terminal?" "What video terminal?" I asked. "Southwest makes it. Goes with the computer instead of the teletype." "Sure," I answered. "Bring it in. By the way, what is your name?" "Ken Stam," he told me. "See you tomorrow." The next day he returned, bringing with him a strange wooden box with a keyboard sticking out of the front and a lot of wires out of the back. In a few minutes, Ken had it hooked to my computer and one of the video monitors in the store. He turned on everything and started typing on the keyboard. Wonder of wonders, the characters he typed started appearing on the video screen. It worked. Soon he was running programs on the 6800 computer. This kid knew something. "How would you like working here after school?" I asked him. "Okay," he said. "I'd like that." The next day, he appeared with more things he said I needed for the 6800. Soon, Ken was on the phone with Southwest ordering all kinds of things for us to sell. He worked for us as long as the Computer Mart of New York was in business and became our expert on SWTPC. In fact, he just about ran that portion of the business. Dan Meyer founded SWTPC in San Antonio, Texas, as an electronics company devoted to building low-cost electronic kits, many of which were originally projects in magazines such as Popular Electronics and Radio Electronics. Some of their products, like the 250-watt Tigersaurus amplifier, enabled hobbyists who were skilled with the soldering iron to have a high-powered audio amplifier for only $154. Southwest also made the Tiger 60-watt amp and a preamp for it. Other products, such as the guitar preamp, input mixer, and stereo octave equalizer, rounded out the audio kit line. Then there was the theremin electronic musical instrument, which was played by moving your hands, and the psychedelia color organs. These, and other products developed as kits for magazine articles, put SWTPC on the leading edge of electronic experimentation. The unusual thing about these kits was that they were priced low so that the hobbyists could afford them, yet they were engineered so they worked well when they were assembled. Dan Meyer carried these principles over to the personal computer business, which was one of the reasons for the long survival of his company. No one was ever mad at SWTPC after completing their computer assembly. 9 out of 10 computers worked the first time when the power was switched on. The first digital product SWTPC built was a digital logic Microlab, which enabled an experimenter to learn about digital logic with the aid of Don Lancaster's RTL cookbook. The second computer product was the KBD2 keyboard and encoder kit. This was a fully ASCII encoded 53-key system with standard digital logic output. It was ready to connect into any video terminal, including a product like Don Lancaster's TV typewriter, which had appeared in Radio Electronics magazine. The amazing thing about this keyboard was its price of $39.95, a true bargain at a time when surplus keyboards cost twice as much. The kit did not make the highest quality keyboard. Its key switches occasionally went bad, leaving you without a character, but it was cheap and easy to fix. Before Southwest built a computer, they made an affordable terminal kit for the many hobbyists and students who were beginning to access college computer networks. The CT1024 terminal kit was capable of displaying 32 uppercase alphanumeric characters on a video monitor or a modified TV set. It could not communicate with IBM equipment, which used the EBCDIC code system, or with the old 5-level Baudot coded teletypes, which were often in use in those days because hobbyists could buy them very cheaply. The CT1024 terminal had a memory composed of 6 2102 static RAM chips, which could store 1024 1K characters. The unit did not have scrolling and was only capable of displaying 512 characters at one time on the screen. This was called a page. You could then flip a switch and display the second page of 512 characters. When it got to the last character position of the last line, the cursor would return to the first character position of the first line. The CT1024 terminal had quite a few optional boards which extended its capabilities. A computer-controlled cursor option was available as a kit. This allowed computer control over the position of the cursor on the screen. Input or output, I/O, for the terminal was provided by adding another kit of parts. You could put together either a serial I/O option or a parallel I/O option. The builder was warned that while the serial option was in accordance with the usual standard for connection, RS-232C, there was no equivalent standard for parallel interface, and therefore it might be difficult to make the interface work. SWTPC recommended that you use the serial kit. Another option was the screen read board. This gadget was used when information that had been typed into the terminal was edited and had to be read out of the terminal and into another device. This was not needed with a computer in the interactive mode. SWTPC would sell you the basic video terminal kit for only $175 without the keyboard, power supply, interface, or cursor control. The complete CT1024 terminal kit was $275 with only the baud rate kit at $1475 and the parallel omitted. The Altair computer was introduced to the world in the January 1975 issue of Popular Electronics magazine, and the personal computer revolution started. However, the Intel 8080 CPU upon which the Altair and later the MSI were based was not the only microprocessor. Motorola had developed the M6800 MPU, microprocessor unit, which was somewhat different from the Intel design. The 6800 MPU was part of a family of chips that made computer design and use quite a bit easier. SWTPC used these chips to design a computer that was simpler to build and program than the Altair design, and cost much less to manufacture. In addition, since SWTPC was an established company, it had the facilities to build the machines, and the organization to meet its delivery dates. When you first looked at the SWTPC 6800 computer system, you noticed it was completely unlike the Altair or MSI computers. All you saw was a black and silver box with a cover made of black grillwork and 2 illuminated push buttons on the front. It might have been an audio amplifier, except that it said SWTPC 6800 computer system in large black letters. There were no red and green lights or rows of switches to set. How did you operate this computer? The secret was in a ROM chip, which contained a monitor program called Mikbug, M-I-K-B-U-G. When you turned on the system, it came to life and permitted your computer to communicate with a terminal. Mikbug was also a mini operating system that allowed you to display and change data in memory, dump memory to tape, load a program, display or change the contents of registers, and jump to and execute a program in memory. It also had a routine for debugging programs. All of these system functions were initiated and monitored by a serial terminal. In addition to these system features, Mikbug understood hex notation instead of machine code needed for programming front panel switches on other computers. Contrast this with the Altair. To make the Altair talk to a terminal, you had to go through the long process to load a bootstrap loader program. If everything went well, you could be up and running within 15 or 20 minutes. This was one more reason the Motorola system was so popular. It made the SWTPC 6800 such an easy-to-use computer that its owners seldom ever had any complaints to talk about. Boring, boring, when the hobbyists got together at the computer club to discuss their problems. The SWTPC 6800 owner just sat and had no problems to contribute. Dan Meyer made this situation a feature of his advertising after a user wrote in about it. We sold a lot of these computer kits to customers all over the world. People would come to New York and head for our store because they had heard that we sold SWTPC products, and we had employees who spoke many languages. Building the SWTPC 6800 computer. The 6800 had very few parts for a computer. Eliminating the front panel board used with the Altair design was a big help, but the integrated 6800 chip family also required fewer support chips. The 9 by 14 inch motherboard came with all the sockets you would ever need, and they were very different from the Altair S100 design, which used card edge sockets and very thin plated LANs on the boards. The SWTPC design used Molex connectors that were long metal pins that stuck up through the motherboard. The circuit cards had sockets which fit over the pins, providing a positive contact. SWTPC provided all the pins for each motherboard. The motherboard held 7 50-pin sockets for processor and memory boards, and 8 sockets for the smaller interface boards. You could parallel another motherboard if you ever needed additional slots. The power supply was large enough to support the full complement of plug-in cards, which originally was 1 PM board, 4K of static RAM, plus 8 interface cards. The design of the motherboard made it simple to build, and although it was tiresome to solder in all of the socket pins, it did not require the close work needed to install S100 sockets, which had twice as many pins per socket. The MPA microprocessor system board, MPA board, was the primary logic board used in the system. It contained the 6800 CPU, the 6830 ROM, and the 6810 scratchpad memory, 128 bytes, for the ROM. The MPA also mounted the crystal-controlled processor clock driver and baud rate generator, plus reset and other circuits. The beauty of the SWTPC design was that the LANs on the cards were very, very broad compared to S100 cards. This made it much easier to solder them and prevented the dreaded soldered bridges. The original memory capacity of the SWTPC 6800 was a huge 16K of RAM. Each MPM memory board had a capacity of 4K, but when you bought the computer system, you got the board with 2K of RAM chips. You could buy the extra memory chips to fill the board, and you could buy extra memory boards. The memory board with 2K was $85, and the additional RAM was $45. 4 memory boards fit into the motherboard for the total of 16K. Of course, later, when 4K chips became available, you could expand the memory, since, like all 8-bit CPUs, the 6800 was capable of addressing 64K of memory. However, the 2K of static 2102 RAM consumed 0.75 amps of power. By this same scale of measurement, if we used the same kind of chips today, 640K of RAM would draw 240 amps of power at 5 volts DC, thus consuming 1200 watts of power. You would need a separate power line to run the computer, and you could not also run the stove in an average house. At first glance, the SWTPC 6800 system did not look much cheaper than the Altair or MSI. They all cost about $475, but with the 8080 based computers, all you got for that price was a bare bones computer. No memory, no I/O, and no software. You only got 4 slots, and even they didn't have all the required connectors. Your $450 was only a down payment on a very expensive computer. With the SWTPC 6800 computer, you got all of the connectors, an operating system and ROM, and a memory board with 2K of RAM for $395. The extra 2K of RAM was only $45, and the I/O board was $35. For $475, SWTPC sold you a kit for a complete operating computer. Of course, you could add to it, but your total final cost was nowhere near the price of an S100 system. Software for the SWTPC 6800. From the beginning, Dan Meyer and Gary Kay, his engineer-designer, recognized that the secret to the success of their computer lay in software. Having the operating system in ROM was a break for them, but more software was essential. Fortunately, there was an assembler program available for the 6800 that could be adopted for their computer. SWTPC made it available to owners for $14.95 in either paper tape for teletype or audio cassette format. This low pricing set the pattern for all SWTPC software. While MITS was charging $150 for BASIC, Dan Meyer set the price by the K. 4K BASIC cost $4, 8K BASIC was $8, and 12K BASIC was $12. Although the SWTPC 6800 did not have Altair BASIC, they had a version written by Robert Uterwick that was one of the best cassette BASICs on the market. The AC30 cassette interface. The greatest need for the early computers was a reliable method of mass storage. The paper tape of the teletype was only available to those who were lucky or rich enough to have access to such a machine, and they were a painfully slow method of saving programs and data. At that time, real computers used digital tape drives that cost thousands of dollars, or the new disk system recently invented by IBM. Computer hobbyists, ever inventive, discovered that they could record the tones of a modem on an audio cassette and save them. When replayed, they would recreate the ones and zeros of a digital data stream, and from that beginning came the cassette data storage method. The only problem was that each manufacturer had a different recording method, and the tapes were not interchangeable. In November 1975, Byte magazine called a meeting in Kansas City to set a standard for the recording of digital data by audio cassettes. SWTPC attended and accepted the resulting Kansas City standard of 300 baud data speed, with 2400 Hz sine wave representing a logical 1 and 1200 Hz sine wave representing a logical 0. As a result, SWTPC built a cassette interface unit capable of supporting 2 cassette recorders and able to control the motors of both the cassette recorders. The unit was designated the AC30 and sold in kit form for $79.50. While this unit was used with the 6800 computers, it never became accepted by any other system because no other company used the standard. Both Apple and Sol computers had a cassette system that was reliable at 1200 baud. The PR40 printer. Low-cost, high-quality printers are the usual thing these days. But I remember when printers cost much more than computers. The Centronics 779 finally broke the $1,000 price barrier in 1977, and Epson was the first to offer a quality printer at $600. Way back in 1976, SWTPC alone found a way to sell a really low-cost printer to hobbyists. Seiko made a print mechanism for cash registers that would print 40 columns, and Dan Meyer obtained these printer mechanisms. His company incorporated them into a little printer that printed 5x7 dot matrix, uppercase only, at a rate of 75 lines per minute. The print line was 40 characters wide on a roll of standard adding machine paper, but it was enough for listing programs or short notes. Such a machine would attract scant notice today, but in those days, a printer for $250 was a great bargain. The PR40 was sold as a kit, although the print mechanism was completely assembled. The electronics had to be constructed and the entire assembly mounted upon one of SWTPC's metal chassis. This completed the full starting lineup for SWTPC, and they advertised widely that here was a computer system that almost anyone could build. I say almost, because we did have some people who ruined their kits. One of them glued all the parts to the board and brought the mess in to be wired so it worked. Another burnt the motherboard by using a torch for soldering. One accountant had such trouble that he kept coming into my store. We became friends, and he eventually became my partner. Needless to say, from then on he kept the books, and my technicians built his computers. At the big computer show in Atlantic City, New Jersey, in the summer of 1976, Dan Meyer and his entire crew came to the Shelbourne Hotel to show off their computer system. Dan was very proud of his complete line. He and all of the SWTPC crew wore t-shirts emblazoned with "Altairs Suck" on the front. This was a little too much for the show management, who did not want to offend their largest exhibitor. Meyer was requested to remove the shirts. However, he had already made his point, and he got a lot of attention. After the show, the SWTPC 6800 continued to do very well. However, things were changing in the industry. Floppy disks were rapidly replacing cassettes as storage devices. At first, when the 8-inch floppies came out, they were too expensive for the price range of the SWTPC customers, although other companies sold them to use with 6800 computers. However, when the 5¼ inch floppies became popular, Southwest immediately designed a system to go with their machines. This started problems that Dan Meyer never expected. SWTPC had no problems with software until the first floppy disks were ready to be connected to the 6800 computers. Bob Uterick, who had written SWTPC Basic, had promised to produce an operating system and actually produced a system called FDOS. There were problems with this system because it only supported sequential files and not random files. To those not familiar with disk files, I must explain that this deficiency meant that FDOS was nothing more than a cassette system used on a disk. You see, a cassette stores programs and data sequentially, like a row of ducks, and you have to search through the entire tape to find what you are looking for. The normal disk operating system, with its random file system, rapidly locates data anywhere on the disk. This is the major advantage of disks over tapes, and without it, the speed advantage of disks does not exist. Well, the lack of such a system hurt the sales of SWTPC systems just at a time when floppy disks were replacing cassettes all over the industry. Finally, Dan Meyer and his staff wrote a specification for a real DOS, and it was implemented by TSC under the name of Flex. This single-user system became quite popular and later was expanded to multi-user operation under the name Uniflex. Another DOS often used with 6800 systems is OS9, which will also run on SWTPC machines with the 6809 CPU. The problem with the disk system also produced terrible strains in the dealer organization. When the system was selling well, Dan never shipped all of the components we ordered. I don't know if this was because demand exceeded production, or because he still sold equipment direct, and the more computers the dealer sold, the greater the demand for add-ons, which often only he could supply. Our strategy was to order much more than we needed. SWTPC would cut our order, and we would end up with the quantity we actually needed. The slowdown in sales hit our store much later than it did others, because a lot of our business came from overseas, but it did affect us. Then I began to notice that we were receiving a lot of packages from Southwest in our daily UPS shipments. I called Kenny in and asked him what was going on. Did he have a large foreign order to fill? He told me that he did not have any unfilled orders, and that stuff was starting to fill the storage cabinets. Then I called San Antonio, and they told me that they were filling back orders that had not previously been shipped. I quickly took an inventory and canceled all back orders we absolutely did not need. However, the damage had been done, and I owed Dan Meyer more money than I could pay him by the end of the month. I called and told him my problem. Dan was not very pleased. "I told you had to pay me at the end of the month, and there would be no extensions," he tartly snarled at me. "Okay, but I have a cash flow problem right now. My taxes are due, and if it comes to a choice between paying my taxes and paying you, it is an easy decision for me to make. I will pay what I can now, and pay you the rest as soon as possible. Just don't send me any more stuff." "Don't worry, I won't. But from now on, you are on a COD basis." "That's your decision," I told him. "You won't find it easy to replace our store in New York." So 3 years of close friendship went down the drain. Later, I met one of his other dealers at a computer show. "How are you getting along with Dan Meyer?" I asked him. "Dan is mad at me," he replied. "He shipped me so much stuff, I couldn't pay for it." I told him of my experience, and when we talked to other dealers, it was the same story. The story we pieced together was probably true, although I cannot completely vouch for it. It seemed that what Dan had done was to repeat an old trick attributed to Henry Ford. He had a commitment to Shugart Associates for a large quantity of floppy disk drives, and they shipped them in every week. If he canceled the contract, they would charge back the price of all his drives at a smaller quantity price. They might also sue him for violating his contract. He was not selling the drives and did not have the cash to meet his payments. So he scrapped together every part he could get and used them to fill all the dealers' unfilled back orders. He shipped them all over the country and thus built up his accounts receivable, which he could borrow against to meet his obligations. The trouble came when the dealers could not pay all the bills on time. I do not know what happened next, since, with my credit cut off and sales of SWTPC stuff declining, I sort of lost contact with Dan. We continued to sell the SWTPC 6800, but with the growth of Apple II, our sales were at a minimum. We finally all but dropped the line as far as selling new computers went. This may have had something to do with Dan's later decision to get out of what we called hobby computers and concentrate on business machines. SWTPC did improve its products. It introduced a new improved 6809 CPU and both a line of 8-inch floppy disk drives and 5¼ inch floppy disk drives. The powerful Uniflex operating system was introduced and much improved terminals, the CT64 and the CT82. SWTPC had always been a kit company. and they never attempted to produce a factory-manufactured computer product. This was completely in tune with the hobbyist market that started this industry. However, only so many people want to actually build their own computer, and by 1978, most of them had already done so, and they were committed to their particular type of machine. The advent of the Apple II, the TRS-80, and the Sol changed the market completely. You could now buy a better computer than you could build, and for less money. The market for kits collapsed. SWTPC then offered their System B, a completely built computer system with 2 floppy disk drives and a terminal mounted in a desk. The system cost $4,495 and had 40K of RAM and 1.2 megabyte of disk storage. It ran the Flex operating system and came with BASIC and assembler. I do not know how successful this system was, but at almost $5,000 I doubt if many were sold. The industry at that time was offering much better value in CP/M systems. However, the SS50 bus was still very strong in the 6800-6809 field, and many special purpose computer devices were sold for industrial purposes. 2 other companies, Gimmicks and Smoke Signal, built SS50 bus machines, and they did very well for a long time. SWTPC eventually withdrew completely from the hobbyist market and only built business machines and special purpose computers that were used in point-of-sale systems and other commercial applications. Please look in the show notes for a link to the article Remembering Stan Veit. Join us again soon for another chapter from Stan Veit's History of the Personal Computer.